everyone, and welcome to another News Coulomb video. I recorded this one already, but I was at the lake and it was a bit windy, so I don't know how the audio quality turned out, especially because I forgot my dead cat in the car. Having gone through it once, it allows me to fix a couple of my errors. And one thing I wanted to mention up front is I'm starting a Substack, and almost all of my videos are going to have complementary, if you will, articles that are written, and not all of them are going to be complimentary. Uh, so Substack has basically a subscription model, and I think I can post some of these articles for free, which I will do, and then the ones that either I put a lot of work into or whatnot, the ones that really get into the nitty-gritty details, stuff like that, those ones are going to be for subscribers only. And part of the reason for that is my videos do get monetized, but it's really not all that much, and I'm not going to do sponsorships or anything like that. I want to make sure that nobody can accuse my channel of having any sort of a bias or special interest or anything like that. So blind advertisers are one thing for monetization, but if I'm going to go through all of the work to put articles together, I might as well actually require a subscription to read at least some of them, if not a majority of them. Again, just because really I'm not asking for Patreons or memberships or anything else like that. If I'm going to do this full time, though, I am going to need to balance out some sort of an income. So this is one of those videos that will have a complimentary or, sister article, if you will, that's written. A lot of people who watch the channel even have stated or commented that they actually would just prefer to read an article. And especially when things get into detail and there's a lot of information and data, it's much easier to find that information within an article and reference it and stop and come back and read it again, right? And then again, if you're paying for a subscription, right, then you're not actually interrupted by ads or anything else, and you can revisit it as often as you want and reference it as you will. So just a heads up, and as these articles get posted on Substack, they will be in the description as well. But this video, I wanted to talk about the upcoming Chevrolet Bolt EV. We've had some spy shots of it. We've had some comments from GM leadership about it. We've had some, independent takes, but I figured I would go over what we kind of know for sure and then give my take on what I expect and what I hope, right, might be the case with the Chevrolet Bolt EV. I have some cliff notes here because, like I said, I did write that article, and so basically what we can reasonably expect, and then, like I said, I'll go into greater detail about what I actually think that means and what consumers should expect from the Chevrolet Bolt EV, and then, like I said, it's some additional maybe pie in the sky stuff that if GM isn't considering it, maybe they should be. So first, what do we know that's confirmed? This will be the first GM EV in the domestic market with an LFP battery. Oh, and by the way, I'm going to roll in some B-roll footage of the 2023 Chevrolet Bolt EUV red line that I reviewed too. I never actually had a chance to do the full formal review. Family issues came up, and so might as well use the B-roll here. Just note this is not the 2026 or 2027, however they end up breaking it out, Bolt EV. So one thing we do know is that it's going to be that LFP battery chemistry. This is much cheaper battery chemistry. Even now, we could be looking at a finished battery pack cost of as low as $80 per kilowatt hour. It might not be that low right away, but I expect it to be significantly cheaper than the nickel, manganese, cobalt, alumina battery that they're using in the rest of the GM EV lineup right now. In addition to that, it's going to be on the BEV2 chassis, which is important in that it facilitates a lot of other options where the Chevrolet Bolt EV previously was built on a bespoke platform. No Sandy Munro and Associates. It wasn't built on a Sonic platform. So it was a bespoke platform specifically for the Bolt EV, and it didn't facilitate things like all-wheel drive, and then of course the newer, I guess previously called Ultium battery technology. So it was an 9-year-old platform, right? That even up until the most recent Bolt EV that they were building it on. So the BEV2 chassis, same one that the Chevy Equinox, Chevy Blazer, the Cadillac Optiq, the Cadillac Lyriq, all of them built on the BEV2 platform. So it's agnostic when it comes to powertrain, all-wheel drive, front-wheel drive, rear-wheel drive, or wheelbase even. Then the next thing that we're reasonably sure of is Global B. The new Bolt EV will have Global B. This is like the interoperability communication software within GM EVs. I believe it's the GM VIP. One of the major things that this enables is over-the-air updates. So the Chevy Bolt EV previously technically had over-the-air update capability. My Bolt EV, my 2017 Bolt EV, technically has it. However, it's limited, I believe, only to the infotainment system. Anything that's mission critical, you're going to have to take it into a service center. I had the battery software updated, I think it was 2018, and I had to take it into a service center for that. That's where they reprogrammed how the battery was reading the energy, and I lost like 2 kilowatt hours of usable, at least per the display. So yeah, that sort of stuff. And then obviously, like when I had my battery replaced, had to go into the service center. So that's hardware, but the software that goes with it also has to be updated in the service center. You can't, there's no over-the-air update for it. And as far as even the infotainment over-the-air update, I don't know of a single Bolt EV that's ever had an over-the-air update like sent out to it. So that should be a little bit more prominent with Global B. We've heard a number of updates for Equinox EV owners and other GM EV owners with the newer EVs. So that's something that will come with the new Bolt EV. Next is Android Automotive OS. So GM is making that switch across the board. This is different than Android Auto. This isn't a phone-based platform. So the Android Automotive OS is integrated into the car. That means no CarPlay. It will be a more natural transition for people already in the Google ecosystem, or if you use Google Maps or anything like that, that will be a more natural transition. If you're dead set on using Apple CarPlay, I don't know what to tell you, but yeah, that's not something that's going to necessarily be integrated into the upcoming Bolt EV. Now with that though, comes the addition of built-in navigation and route planning. And that's something that was missing from the Bolt EV before. You could only do that through a phone-based app. And this is an important change because with Android Automotive OS integrated, it gives you information about the battery. It gives you information about what your energy consumption currently is, or what your expected remaining energy when you arrive at your destination should be. So this is that integrated route planner and navigation that a lot of EV owners want. And so that is made possible by an integrated Android Automotive system. And then of course, option for things like battery preconditioning that should be available in this new Bolt EV, and it should be available through navigation. When the conditions are appropriate, a driver controlled preconditioning, and then also Super Cruise. Now the 2023 Bolt EUV Redline that I tested did have Super Cruise, but it was a limited Super Cruise. It wasn't getting updates as far as I know. It wasn't as capable as the Super Cruise that was available in like the Hummer EV and the Lyriq just not too long after that, right? And so the Bolt EV should have the option, the new Bolt EV should have the option for Super Cruise. It's not going to be like included in the base model or something, but somewhere along the spectrum, I mean, it might be an option even for the base trim, but I kind of doubt it. I'm guessing that they're going to have some sort of a comfort and convenience and technology package that then unlocks the option. And then, of course, Super Cruise going to something like a subscription. Not the greatest thing, but at least for those who are interested in having a hands-free, updatable driver support system, Super Cruise is going to be a great option, and it should be available in the new Bolt EV. Just expect to pay extra for it. And then, of course, the other thing that we kind of know for sure is it's going to have a J3400 NACS plug. So there's been talk about where this should be located. I really hope that if they do it for the Bolt EV, they do it passenger side front. This is the way that they're going to allow Bolt EV owners to use the superchargers if they choose and not have to back into them. A Bolt EV isn't going to be towing or anything like that, so there's no need to have it in the rear, driver's side rear, like what you see with the Chevy Silverado EV or the Sierra EV or the Hummer EV. Those vehicles can tow, so you want that charging point at the rear so that when you have a trailer, it's always at the middle point, no matter where you're, when you're towing and pull through sites. It's just a much easier, better location for the charge port to be for those larger vehicles. However, for smaller vehicles, it's generally better to have it near the front. And if you can't have it driver's side front, you could have it passenger side front, and then that way it would facilitate, like I said, those who want to use the Tesla superchargers. But, for those of you who saw me visit the BP Pulse, they're already putting out a lot of these NACS J3400 plugs. So even if it was passenger side front, it's just native now. All right, so now I want to talk a little bit about what my take is based on this information and where I think that they're going to go. I think, let's start with the motor. I think the new Chevrolet Bolt EV is going to have the same powertrain as the front-wheel drive Equinox EV. And what does that mean? It means that it's going to have a 180 kilowatt permanent magnet AC motor, front-wheel drive, 11.59 to 1 gear reduction ratio. And just doing the back of the napkin math on that, the old Bolt EV had a top speed of about 92 miles an hour. With this new motor, it should have a top speed of about 100 miles an hour. So it's increasing that reduction gear ratio from 7.05 to 1 to 11.59 to 1. But it appears that those, I'm just going to call them Ultium, formerly known as Ultium. The Ultium motors that GM is using, those have a peak RPM, it looks like over 15,000. The old Bolt EV, Old Faithful, it has a peak RPM, motor RPM of 8,800 RPM. So it's mechanically limited to 92 miles an hour. If we're assuming that same sort of mechanical limitation for the new Bolt EV and roughly, like I said, 16,000 RPM peak for that 180 kilowatt motor, then you're going to see a peak top speed of 100 miles an hour. It's more than enough, but, especially with some people driving roadways with 85 mile an hour, 90 mile an hour speed limits, an extra 10, 15 miles an hour can actually get you out of problems. It can also get you into them. So with that too, I would expect the performance to be roughly a 5.5 second 0 to 60 time. I'm assuming that the curb weight for the Bolt EV, the new one, is going to be somewhere around 3,800 pounds. But I'm just saying, let's say it's less than 4,000. So that's going to be one of the lighter GM electric vehicles right now. I mean, it's possible that it weighs a little bit more than that, but this version, the older version of the Chevrolet Bolt EV, curb weight was around 3,500. Even going to LFP batteries, which will be slightly less energy dense, at the pack level, they aren't going to lose that much. And the rest of the vehicle should get away with being lighter and smaller. So I'm expecting at least a sub 4,000 pound curb weight. Combine that with a 180 kilowatt motor, and yeah, about 5.5 second 0 to 60 time. And then let's talk a little bit about that battery, that LFP battery. Like I said, I don't expect it to be lighter than the current Bolt EV battery, but I also don't expect it to be that much heavier. LFP has come a long way, and we have to remember that the Chevrolet Bolt EV's batteries it's 9-year-old technology at this point. They were heavily energy dense on the nickel manganese cobalt chemistry. Part of the reason it has a 1C or kind of sub 1C charging rate. There are other reasons as well, but even if you unlocked the charging harness and gave it more than 150 amp current limitation for charging, it still wouldn't charge faster than like 1.1C. I think we saw peak for these cells with the Hyundai Kona EV, right? Like a 70, 75, maybe 80 kilowatt in a 65 kilowatt hour battery pack. So that's about all you're going to see in this older version, right? But the newer version with the LFP, I have a few thoughts about where they're going with this. My take is they're going to be using 100 amp hour LFP prismatic cells. Now, that does mean that they aren't going to be as fast charging as some of these EVs that we're seeing come out of China with 4C, 5C, 6C charging rates. You know, CATL, BYD, they're all advertising these super fast charging LFP EVs. But that's because they're doing exactly what I've mentioned in the past, where they're thinning down that electrode so that they're using 25, 30, 35 amp hour LFP cells that are fairly thin, so they have a really high C rate. And then they're just packaging a bunch of them together. GM could go that route, but I kind of doubt it. I actually think that they're going to go the route of 100 amp hour cells, which it's there to reduce cost, right? So there's no reason to add additional cost and reduce energy density by making them higher power when you already have a higher power option in the NCMA, right? So just leave the NCMA where it is, and then, you know, do the higher energy density LFP cells, even if it means sacrificing a little bit of energy density. So my assumption is the new Bolt EV is going to have cell groups of 200 amp hour cells. And typically in an automotive application with thermal management systems, those cells can charge at a 2C rate. That's entirely reasonable, and there shouldn't be a problem with it. Now, what about the actual overall energy capacity? Because 200 amp hours is roughly the same as the current Bolt EV, actually a little bit more. The difference is really going to come down to the voltage, and what I haven't figured out is how many LFP cells they are going to put in series, because LFP has a slightly different voltage than the NMC and NMCA that GM is currently using or was previously using. And so changing up how many of those cells you have in series will change that voltage. At a very minimum level, I would expect 96 LFP cells in series, or cell groups in series, with, like I said, 2 cells per group. So it'll be 96S2P. And that will give an overall pack voltage of a little over 300 volts nominal and 61 kilowatt hours of total capacity. Now, when it comes to charging, though, if it is a 2C charging rate, what we can expect from that is that a charge from 10% to 50% will take roughly 15 minutes, and a charge from 10% to 80% should take maybe 25 minutes. And now there is a possibility with LFP that even if it's doing a 2C rate or a 3C charging rate, that there are step downs, and similar to what you see in nickel-based battery chemistries. It's less likely, and usually you can charge at the peak rate for longer. But even if there were a step down, right, where it charged to 50% at 2C and then it steps down to like 1.5 or even 1C from 50% to 80%, that would still mean that you're charging from 10% to 80% in about 30 to 35 minutes, which actually is the same speed or a little bit faster than what the 85 to 90 kilowatt hour Chevy Equinox EV charges at. So we're talking about charging time, though, not charging speed, because this would be done with maybe 120 kilowatt charging, somewhere between 110, 120 kilowatt charging. And like I said, 15 minutes from 10% to 50%. That should be sort of the benchmark for that 2C rate. And then 10% to 80% in about 25 minutes, if it can maintain that flat charging curve or flat charging profile. Now, with that, though, also I expect the Bolt EV in terms of charging to have the same onboard 11.2 kilowatt charger. So that's not going to change at all. 6 to 8 hours to charge from empty to full. Again, these are sort of the baseline expectations. I expect the overall cost for the vehicle to come in at under $25,000. So I would be looking at a MSRP for the base Chevy Bolt EV 2026 or 2027, whatever model year they end up releasing it as, at $24,995. So it's going to be one of the cheapest all-purpose, fully capable EVs that you can buy new in the United States. And I think that's like, it could even be less than that. But I think that is the minimum expectation right now out the door. And then the other thing I want to talk about too is volume production. GM, because they aren't relying on LG as a company to put together a pack for them, production sky's gonna be the limit. And this is something that a lot of people didn't realize about the older Bolt EV. It got panned a lot because of, they're only building 25,000 of them. But if you rewind the clock, 2016, LG was one of the largest battery makers in the world. And the Bolt EV alone, those 25,000 batteries basically a year that GM was ordering from LG for the Chevy Bolt EV, alone represented between 20 and 25% of LG's total global annual battery production. So at that point in time, there wasn't a possibility to build more. And I would go even further, as we saw with like the Hyundai Kona EV coming online using very similar battery cells, and we saw Jaguar with their I-Pace using similar battery cells, as time went on, GM's allocation from LG just didn't increase because there were too many other people coming in and buying those batteries in bulk from LG. So there was a real battery constraint. So what do I expect in terms of production and sales? If they're selling a $25,000 Bolt EV, my expectation is that we're looking at least 4 times as many as the Equinox EV. And if that's correct, we could be looking at, even from the opening out the gate, first year of production, they could be selling 160,000 Chevrolet Bolt EVs in the first year. So just the Bolt EV alone would double Chevrolet's domestic US EV sales. That's my prediction. So GM, if you have someone in there telling you you need to build fewer than that, or you need to be capable of building fewer than that, or not ramping up production to support that level of demand, ask them to reconsider. One other thing that I forgot to mention on this is efficiency, right? The Chevrolet Bolt EV is one of the most efficient EVs that GM has ever produced. And in the modern era, it absolutely is the most efficient EV that GM has ever produced. So with that, right, you're looking at a reasonable 3.9 to 4 miles per kilowatt hour. I don't actually expect that to change for the new Bolt EV. They could even possibly lower the roof line. There was already comments I saw about them extending the nose out. My guess is that's to facilitate the larger powertrain, which will be bigger than the outgoing Bolt EV. Some of it could also be styling. But overall, if they can make it a little bit sleeker, like I said, they could get away with lowering the roof. I mean, if you're 6'7", 6'8", I mean, it's great that you can fit in this car, but you lower the roof line by an inch or two and you could significantly improve the efficiency without taking a whole lot away from the consumer experience. So with that 61 kilowatt hour battery pack, base expectation 4 miles per kilowatt hour, I would expect, again, bare minimum expectations 250 miles of range. So this kind of flies in the face of what Mary Barrow was saying about the new Bolt EV being better than the old Bolt EV in driving, traveling, and charging right experience. So this is why I'm actually thinking there could be some credence to some of my pie in the sky ideas about where they could be going with the Bolt EV. Of course, the other thing too is a heat pump. And before everybody gets all crazy with the heat pump, you know, you're going to probably see a 5 to 10% gain in winter over a Bolt EV that doesn't have a heat pump. And this is based on my experience of, you know, never really seeing more than 5 to 10% of the total energy going to cabin conditioning. Sure, and I've heard some people say, oh, they've seen 20, 25%. But if you're talking about driving 20 miles an hour in a city in sub-freezing temperatures, sure, maybe there can be some exceptional circumstances where your energy consumption for heating is really, really high. Other than that, right, a heat pump is only going to save you maybe, like I said, 5 to 10%. But hey, going from a 200-mile EV in winter to a 210 or 220-mile EV, that is a notable improvement. But what I will say is this too. One of the areas where heat pumps in cars still struggle is in defogging. And so if you are in a humid climate, you just might not see as much of an improvement as you'd hope for, because it's going to end up using the same systems as a standard heater cooler, right, to defog the windows. So it's going to be the same energy consumption when you're defogging. And I've also heard that the GM heat pump is maybe a little bit noisy, so hopefully they can address that. But like I said, I just don't think it's a panacea. I think there are some unexplored options for winterizing an EV that automakers just haven't even bothered with yet, and that's unfortunate because I think it could go a long way. And then, so let's just close with my pie in the sky thinking. I'll start with what I think could still be reasonable, and that is that rather than doing a 96S 2P with 200 amp hour cells, GM could do a 108S 2P with 200 amp hour cells. The voltage doesn't make all that much of a difference. LFP has a very flat voltage, and so what you end up with is closer to a 350 volt nominal pack, but an overall capacity of 69 kilowatt hours. With that 4 mile per kilowatt hour efficiency, now you're looking at an EPA estimated combined range of about 275 miles, which is really significant. Not as good as the Equinox, so they're also not really affecting that name sticker, with a in-house stablemate competitor. But then again, the Blazer and the Equinox EV sit right next to each other, right? So are you saying that the Equinox can't outshine the Blazer EV in some ways? Because clearly it can. And the Bolt EV may be able to as well, especially, like I said, in that charging time, going from 10 to 50% in 15 minutes. Now all of a sudden you're adding a lot more range in a lot shorter period of time, or especially if you're charging to 80% in 25 minutes. So each stop is saving you 10 minutes over an Equinox, and you're adding very similar amounts of range. Yeah, I think it's just going to be a huge boon. And then, of course, time for the lights to come on. And then again, because you're talking about a BEV2 platform, one of the other things that is possible for GM to do is make an all-wheel drive version of the Bolt EV. Now, we're no longer talking about the $25,000 version. We're talking about moving up in price. But then the other thing is, too, they could even get spicy and do a Bolt EV SS, which would be really interesting. And again, this is all of that pie in the sky is, what if they did say, hey, you know what, let's just future-proof this Bolt EV, and rather than using 100 amp hour cells, let's use 25 amp hour cells. And instead of doing, a 108S 2P with 200 amp hour, we do 96S 8P with 25 amp hour cells, and now we have a 60 kilowatt hour battery pack that can charge from empty to 80% in about 10 to 15 minutes, right? That same 3C, 4C that we're seeing from CATL, that we're seeing from BYD. Maybe that could up the price. It would give the Bolt EV higher power density. You're going to suffer with range, but a lot of people had said, hey, look, 220, 230 miles, that's more than enough for me. If I can add 80% of that in 10 to 15 minutes, I'm good. Right? So then we would be looking at a Bolt EV that's charging from, like I said, from 10% to 80%, seeing peak charging rates of 180, maybe 250 kilowatt even, and holding it for a majority of the charging session. So that would be the real spicy meatball that I could, that's the pie in the sky that I could foresee them doing. We'll have to see. LFP is pretty new. Like I said, I would expect them to go with the simplest, cheapest route first, which will be the larger format cells, the thicker cells, fewer connections, fewer things to go wrong, cheaper to produce. I mean, that was the trademark of the Bolt EV, was this value proposition of a high amount of range and decent efficiency, right? And low upfront cost. So that's kind of my expectation. And then I just wanted to close with LFP in general. I think there's going to be a learning curve, both for the automaker, but also for the end user, because LFP chemistry has a very flat voltage profile compared to nickel-based batteries, which have a linear voltage profile. And so the behaviors are very different. And one of the things with LFP is once you hit the peak charging voltage, it really just starts to saturate, right? And then the cells are just sitting there absorbing more and more energy, and you really don't have a good voltage indicator for how full a cell is. And so on the automaker side, they can abate that somewhat by basically putting in, Hall sensors and ways to track the Coulombic transfer of energy, right? How much energy actually went through the system into the battery. So they have a way of estimating that outside of the battery voltage. But once that energy is in the battery, the voltage makes it really, really hard with LFP to know what state of charge you're actually at. How full is the battery? Because you can look at an LFP cell that's 3.3 volts and it could be 80% full or it could be 50% full. Who knows, right? Because the voltage is just so low. And like I said, you pull power after it reaches peak charging voltage, those cells will immediately start dropping down to a lower voltage state where they just sort of settle. And it's to the point where probably 90% of the cycle for an LFP cell is going to fall within like a 3.1 volt to maybe like 3.4 volts per cell. Like a 0.3 volt range is representative of about 80 to 90% of the voltage that you're going to be drawing from, or the energy you're going to be drawing from the battery. So it's really hard to tell. And what that also means, even from an end user, is if you charge to full one day and you do a route and you use 80% of your battery doing that route, you could charge to full the next day and same exact conditions, and maybe you use 85% of your battery, or maybe you only use 75%, because you just don't know the amount of energy that you put in. Like the LFP cells will just sort of self-saturate after a while. And this is also why it's not as important for things like the Hilltop Reserve or the target charge level that previous Bolt EVs had. There will still likely be a target charge level for the new Bolt EV. It's just really not that important to use it. One of the reasons they say with LFP specifically to charge to full is because when the cells are less than about 3.5 volts, again, it's really hard to tell how much energy is in them. So balancing them at that point is nearly impossible. You're wasting your time until you get way past 3.5 volts, or way past, I'd say, 3.4 volts to really know that you're properly balancing the cells. And that's why they say just go ahead and charge it to full. The lifespan of these batteries is just so long anyway. We're looking at 4 to 5 times the cycle life for LFP than you get out of even the best nickel-based batteries. So charging to full just really isn't a huge deal. LFP batteries just suck up energy and they just keep sucking them up. And then, like I said, it's just be aware of that. And we'll have to see how GM does with this, but it might also be worth it if you're DC fast charging on a trip, rather than looking at what the system has, see how much energy the charger says that it provided. So if it gave you 40 kilowatt hours one session, and then the next session it only gave you 30 kilowatt hours, and you're at a similar state of charge, you know something's a little bit different. So just something to be aware of, and we'll see. I mean, I think it's fair to say, at least in the U.S. domestic market, we're all sort of pretty new to LFP. DIYers have been using LFP for a while, but when you were talking about it integrated into a factory built EV rather than like a grid tie or something else, these behaviors are going to probably be different than the nickel-based batteries. So we'll just have to pay attention to that. But outside of that, I'm just kind of curious what your take is, what you think of the upcoming Bolt EV, where you think maybe I went wrong, maybe where I didn't go far enough. Would you be satisfied with a $25,000 Bolt EV with 250 miles of range and a 60-ish kilowatt hour battery pack, if it could charge to 80% in under 30 minutes? Would that be acceptable to you? Or would you, for that money, kind of expect, say, like a 275 mile range, 69 kilowatt hour battery pack, and then again also being able to charge to 80% in like 25 minutes? Or are you at the point now where if it's not charging at that 3C, 4C, 200 plus kilowatt charge rate, you're not even looking at it, right? So yeah, in one other consideration I was going to say too is the Bolt EV will be less sensitive to the high power charger current rates than what we see with the Equinox EV and the 85 kilowatt hour Chevy Blazer, right? So those both require that 500 amps. If I'm right, unless they go crazy with the charging rate, the new Bolt EV should probably see its peak charging rate around 400 amps. So, and then if they're using J3400 NAX plug, that could be rated as high as 600 amps. But either way, there should be available capacity through the charging port to accept additional energy from the charger without taking away from the charging speed, which is a really important factor when it comes to running battery conditioning and cabin conditioning and not impacting the charging curve of the battery or charging speeds of the battery. So if there's that overhead built into the charging harness and the charging port as well, then yeah, we could be seeing a very capable, resilient, consistent charging Bolt EV. So yeah, I'd love to hear what you think. Like I said, maybe where I went wrong, where I went right, what you're hoping for. We'll find out from GM soon enough what they're up to. But yeah, I think I'm looking forward to Chevy Bolt EV. I've got high hopes for it. It's what I've said that the market is needed for a very, very long time. And it's going to be probably the closest thing we have to the equivalent of the EVs that we see coming out in China for less than $30,000 right now, basically from any automaker. So might as well be GM. But like I said, I think GM also needs to go in with the expectation that they're going to be selling hundreds of thousands of these cars a year. So as always, thank you for watching.